This is a chemistry course at a liberal arts college, so in addition to the chemistry, I try to make connections to other subjects that you study. So at the beginning of the course, we do a little bit of history of chemistry, and from time to time we talk about the philosophy of science, and of course there are lots of connections to math and physics and biology. Today we're going to do something a little bit different. We're going to talk about chemistry and language. Because we think of English teachers stereotypically as being very picky about language, like,
"Don't say ain't."
But actually every field has words with very specific meanings. Let's make a table of words like that you've already had in this course. At the top of the table will be a sentence with blanks, and I'll put the columns of the table under the blanks. People usually say blanc when they really should say blanc. So let's go through some of the examples we've already had this year. At the beginning of the year, we talked about the words precision and accuracy. People tend to use those words interchangeably, synonymously with one another, but actually they have different meanings that matter in chemistry. Precision is the absence of random error, while accuracy is the absence of systematic error. Similarly, people often say, "I have a theory about that," as if to suggest something very speculative. But we know that not all theories are speculative. Some are very well established, like Dalton's atomic theory or Einstein's theory of relativity. So they really should say, "I have a hypothesis about that." But they don't. And they probably never will. And people often talk about having proof, like the insurance company wants me to provide proof that I've lived in this state for the last 6 months. Well, I can give them my driver's license and my voter registration card, and they're pretty strong evidence that I've lived in this state, but I can't provide absolute proof. How do they know I didn't fake it somehow? What they really should ask for is evidence, not proof. And here's one that I find very amusing. People call this tinfoil. It's aluminum foil. It hasn't been made out of tin since like the 1930s. But it's funny that people in your generation still call it tinfoil. And it really doesn't matter, except if you do like we did in a lab earlier this year and use the aluminum foil as a reagent in a chemical reaction. And then it's kind of important to use the correct reagent, so you can't just call it tinfoil then. And then here's one that drives chemists up the wall. People use the word chemical as in,
"Are you going to eat that apple? It has chemicals on it."
well, it is made of molecules, but by golly, I'm going to eat it anyway. What they really mean to say is it has artificial substances on it, man-made substances, things like pesticides that might not be good for you. And similarly, people say organic when they mean natural, coming from nature. So if you eat a bunch of organic foods to prepare for organic chemistry next year, might not work too well. Here's a solution of sodium hydroxide and water. I'm going to add some phenolphthalein to it, and the solution will turn pink. So I'll mix that around a little and transfer some to this other flask. And now I'm going to add some vinegar to neutralize the base, and the solution will turn clear. Do you think it's clear? Say clear. It's not clear. Well, the solution is clear, but the right word to use isn't clear. Clear means transparent, means you can see through it. And I can see through this one, but I can see through this one too. Clear is not the word that distinguishes this solution from this one. This one is pink, this one has no color, it's colorless. People usually say clear when they really should say colorless. People think that the opposite of colored is clear, but it's not. The opposite of colored is colorless. The opposite of clear would be something that you can't see through. That word would be opaque. So why did I pick now to talk about this? Well, now is in general chemistry at the end of the chapter on solutions. And the chapter began with this definition. A solution is defined as a homogeneous mixture. So is milk a solution? It says homogenized right on the container. That sounds pretty homogeneous to me. But milk is not a solution. With this solution, you can magnify it and magnify it and magnify it some more, and it's still homogeneous. You have to magnify it all the way to the level of molecules before it becomes lumpy, before it becomes heterogeneous, before you can say, there's a water molecule, a sodium ion, an acetate ion, another water molecule. Until you magnify it that much, it's homogeneous. Milk doesn't have to be magnified that much. You just have to put it under a microscope and you can see the clumps of butterfat. Milk is not a solution. It's called a colloid. So do we need sophisticated instrumentation to distinguish a solution from a colloid? No. Do we even need a microscope? No. All we need is to look at it. Solutions are clear. Colloids are opaque. And that's why chemists are so picky about that use of language, about the correct use of the word clear. So if a mixture seems homogeneous but is opaque, then it has particles big enough to scatter light. That's called the Tyndall effect. It happens because the wavelength of the light is about the same as the size of the particles that are scattering it. So it's not really homogeneous, it's not a solution, it's called a colloid. An exception would be pure copper is a metal, it's not clear, can't see through it. Can't see through pure zinc either. When you mix them to form brass and alloy, it's not clear either, but alloys are solutions. The reason brass isn't clear is that pure substances from which it's composed aren't clear. So at the beginning of the course, we differentiated matter into pure substances and mixtures. Pure substances could be elements or compounds, and mixtures could be homogeneous, in which case we call them solutions, or heterogeneous. And now we see that it's more complicated than that. There's not a sharp dividing line between homogeneous and heterogeneous. That's a pretty fuzzy area between them. So if it's truly homogeneous to the molecular level, it will be clear, transparent. That's a solution. But if it looks homogeneous and opaque, then it has particles big enough to scatter light. It's not really homogeneous to the molecular level, so it's not really a solution. It's called a colloid. Remember, solutions don't have to be liquids. Air is a solution of gases, and brass is a solution of solids. It's the same with colloids. They can be composed of solids, liquids, or gases. And a lot of important things are colloids. What's the difference between fog and humid air? Both are mixtures of water and air, so what's the difference? Well, you're looking at me now through humid air. It's clear, so you can tell that the mixture is a solution, that the water is dispersed as individual molecules. By contrast, can you see through fog? Not very far. If you're driving through fog, you have to put your lights on. Fog blocks light. It's opaque. And so you can infer that there must be little droplets of water that are scattering the light, even though you can't see them. Fog is a colloid. Smoke is a colloid. It's a mixture of a solid and a gas, soot particles in air. The soot particles may be too small to see, but we can infer their presence because smoke is opaque. Paint is a colloid. Paint is intended to cover up what's underneath it. It's supposed to be opaque. That's why we make it a colloid. Butter, whipped cream, ketchup, mustard, mayonnaise. Just think of all the substances you know that look homogeneous but are opaque. They're all colloids. Jelly beans, ink, styrofoam, blood. So I went to pick up these glasses for the first time, and I got these prescription sunglasses at the same time, so the optician says,
"Try on the clear ones first."
And I said, "They're both clear." And she slapped me around a little, so I backed down, but it's tough, you know. Crusading for the English language, it's an uphill battle.
Chemman, scientific method. Hypothesize and test it if you can. Matter, how do we describe it? Compounds, elements, homogeneous.